Hey everyone, welcome back to the channel. Today we're diving into one of the most fascinating and important areas of natural language processing, low-resource language NLP. Did you know that out of the 7,000 plus languages spoken worldwide, only about 100 languages have enough digital data for modern NLP systems to work effectively? That means over 98% of the world's languages are being left behind in the AI revolution. But here's the exciting part. Researchers and engineers are developing innovative techniques to bridge this gap. Today, we'll explore how NLP is helping preserve endangered languages and how cutting-edge methods like transfer learning and zero-shot translation are making it possible. We'll cover three main topics. First, the challenge of low-resource languages. Second, how NLP helps preserve endangered languages. And third, the game-changing techniques of transfer learning and zero-shot translation. Let's get started. So, what exactly is a low-resource language? Simply put, it's a language that lacks sufficient digital data for training modern NLP models. To put this in perspective, English has billions of web pages, millions of books, and countless datasets. But languages like Quechua, spoken by millions in South America, or Cherokee, an indigenous North American language, have only thousands or even hundreds of digitized texts. Think of it as a data pyramid. At the top, we have high-resource languages like English, Chinese, and Spanish. In the middle, medium-resource languages with some digital presence. And at the bottom, the vast majority, low-resource languages struggling for digital survival. But why is this such a problem? Well, modern NLP models are data hungry. They need massive amounts of text to learn patterns, grammar, and meaning. Without this data, we can't build translation systems, voice assistants, or text analysis tools for these languages. And here's the alarming reality. UNESCO estimates that one language disappears every 2 weeks. When a language dies, we lose unique knowledge, culture, and perspectives that can never be recovered. Now let's talk about the good news. NLP is becoming a powerful tool for language preservation, and here's how. First, digital documentation and archiving. NLP tools help linguists and communities digitize oral histories, traditional stories, and cultural knowledge. Speech-to-text systems, even basic ones, can transcribe elder speakers' recordings before it's too late. A great example is the work being done with the Yawanawa language in the Amazon. Researchers used NLP tools to transcribe and analyze hours of recordings, creating the first comprehensive digital database of the language. Second, educational tools and resources. Imagine a child from an indigenous community being able to use a language learning app in their native tongue. NLP enables the creation of spell checkers, grammar correctors, and even interactive learning platforms for endangered languages. Projects like the Endangered Languages Project use NLP to create dictionaries, flashcards, and pronunciation guides that make learning accessible to new generations. Third, community engagement and revitalization. NLP-powered tools like social media keyboards, predictive text, and even simple chatbots encourage daily use of endangered languages. The Maori language revitalization in New Zealand is a perfect example. By integrating Maori into digital tools, they've seen increased usage, especially among younger speakers. Fourth, linguistic analysis and documentation. NLP algorithms can analyze language structure, identify unique grammatical patterns, and even discover connections between related languages. This helps linguists understand and document languages faster than ever before. Now let's talk about the technology that's revolutionizing low-resource NLP. Transfer learning. So, what is transfer learning? Imagine you learn to play the piano and now you want to learn the keyboard. You don't start from scratch. You transfer your knowledge of music theory, hand coordination, and rhythm. That's exactly what transfer learning does for NLP. In traditional NLP, we train a model from scratch for each language, requiring massive amounts of data. But with transfer learning, we train a model on high-resource languages first. This is called pre-training. Then we fine-tune it on the low-resource language with just a small amount of data. The process works like this. Step 1, pre-train a large model on billions of words from high-resource languages. Step 2, the model learns universal language patterns like syntax, semantics, and context. Step 3, fine-tune the model on the low-resource language with just thousands of examples. Step 4, the model performs surprisingly well. One of the most famous examples is MBERT, multilingual BERT from Google. It's pre-trained on 104 languages simultaneously. Even if a low-resource language has limited data, MBERT can leverage patterns from similar languages. Let me show you a quick code example of how we can use transfer learning with the Hugging Face Transformers library. Here, we're loading a pre-trained multilingual model and fine-tuning it on a low-resource language dataset. Notice how simple it is. Just a few lines of code can give us a powerful NLP model. The results are impressive. Studies show that transfer learning can improve accuracy by 20 to 40% compared to training from scratch, even with just 1,000 training examples. What's even more exciting is cross-lingual transfer. Models trained on Spanish can help with Quechua. Models trained on English can help with Native American languages. The linguistic similarities are leveraged automatically. But wait, what if we have zero data for direct translation? That's where zero-shot translation comes in, and trust me, this is mind-blowing. Zero-shot translation means translating between two languages without ever seeing a single example of direct translation between them. Sounds impossible, right? But it works. Here's how. Imagine you want to translate from language A to language B, but you have no A to B translation data. However, you have A to English and English to B translations. The model learns to use English as a bridge language. Modern multilingual models like Google's M2M100 or Facebook's NLLB create a shared semantic space where all languages exist. The model learns that dog in English, perro in Spanish, and chien in French all point to the same concept. So when you ask it to translate from Swahili to Korean, two languages it has never seen together, it maps Swahili to the shared semantic space and then maps from there to Korean. It's using its understanding of language universals. Let me give you a real example. The NLLB model from Meta can translate between 200 languages, creating 40,000 translation directions. Most of these pairs have never been seen during training. Here's a quick code demonstration of zero-shot translation using the M2M100 model. Look at how straightforward this is. We're translating between languages the model may have never seen paired together, and it works remarkably well. The results? In many cases, zero-shot translation achieves 70 to 80% of the quality of supervised translation. For endangered languages with no parallel data, this is revolutionary. Now let's look at some real-world applications that are making a difference right now. Case Study 1, the Masakhane project. This is a grassroots initiative by African researchers to advance NLP for African languages. They've used transfer learning to create translation models for languages like Yoruba, Igbo, and Swahili. Their approach? Community-driven data collection combined with transfer learning from multilingual models. They've proven that even small communities can build effective NLP tools. Case Study 2, Google's 1,000 Languages Initiative. Google announced a project to build AI models supporting the world's 1,000 most spoken languages, many of which are currently low resource. They're leveraging zero-shot learning and massively multilingual models. Early results show promising translation quality even for languages with minimal training data. Case Study 3, Australian Indigenous Languages. Researchers are using transfer learning to build speech recognition for Aboriginal languages, helping document oral traditions before they're lost. The impact is real. Elders can now record their stories, children can learn through apps, and communities can preserve their heritage digitally. But let's be real, this technology isn't perfect. There are significant challenges we need to address. First, data quality. Even when we have some data for low-resource languages, it's often inconsistent, poorly transcribed, or lacks proper annotations. Garbage in, garbage out. This applies to transfer learning too. Second, linguistic distance. Transfer learning works best when languages are related. But what about language isolates like Basque or languages with completely different writing systems? Third, cultural context and bias. Models trained on English might impose English-centric concepts onto other languages. This can distort meaning and miss cultural nuances. Fourth, computational resources. Even though transfer learning is more efficient, it still requires significant computing power, something not always available to the communities that need these tools most. And finally, ethical considerations. Who owns the data? Who benefits from these technologies? We must ensure that language communities control and benefit from NLP tools built for their languages. So, what does the future hold for low-resource language NLP? I'm actually really optimistic. Emerging technologies like few-shot learning, which needs even less data, and self-supervised learning, which learns from unlabeled text, are pushing boundaries further. Multimodal learning is another frontier, combining text, speech, images, and video to learn about languages in richer ways. Imagine learning a language from videos of daily life in indigenous communities. We're also seeing a shift toward community-driven AI, where the speakers themselves are involved in building and training models. This ensures cultural appropriateness and community ownership. And here's where you come in. Whether you're a developer, linguist, or just someone passionate about languages, there are ways to contribute. 1. Contribute to open-source projects like Masakhane or Common Voice. 2. If you speak a low-resource language, help create datasets. 3. Spread awareness about language preservation. 4. Support organizations working on endangered languages. So let's recap what we've learned today. Low-resource languages face digital extinction, but NLP offers hope. Transfer learning lets us leverage knowledge from high-resource languages. Zero-shot translation enables translation without direct examples. And real-world projects are already making a difference. Every language represents a unique way of understanding the world. Every language lost is a library burned. But with these technologies and community commitment, we can preserve linguistic diversity for future generations. If you found this video helpful, please like, subscribe, and share it with others interested in NLP or language preservation. Drop a comment below. Are you working with any low-resource languages? What challenges have you faced? Thanks for watching, and I'll see you in the next video. Keep learning, keep coding, and keep preserving our world's linguistic heritage.